this is the model of the measurement principle. And I put the optical fiber at the screen, and we put the optical screen. This distance was about 3 centimeters. And the probing, the shape of the probing is like a banana shape. And this is the cerebral cortex. The thickness is about from 2 to 5 millimeters. And this cerebral cortex is very important, so it's like a CPU or memory in the computer. And we try to measure this cerebral cortex functions. And when the cerebral cortex activated by something, each cell should consume the oxygen. Then increase the blood regionally because in order to supply the oxygen at the activated area. And so if here was activated by something, and blood come here, and the blood light was absorbed by blood. So finally, we can detect the signal change. So for example, if the blood increased, the signal was light was absorbed by blood. So finally, the increased light. Finally, the signal decreased. That is a very simple principle of the probing. And then we put a lot of the optical probe or irradiation. Red one is irradiation and blue one is a detection. If we set a large number of the optical fiber on the head, we can measure the whole area of the brain. And the surface of the brain function is like that. And for example, frontal lobe has a function of working memory and attention and planning. And temporal lobe has language of speech and language of listening. And the occipital lobe has the function of vision. And this area played a role, control the motor function like moving finger and sensory. And we are using the light so we can observe the functional activity in real time. And this is the first study of the using the optical probe system. And at first we put I made this thermoplastic helmet, and we put the optical fiber like that. And in the case of the motor function, left hemisphere controls the light movement. For example, if I move the right hand, now this area is working. So in this study, we have to get the evidence this system can measure the brain function. So this is the result of oxygen and hemoglobin concentration. And at first, we measured left hemisphere here. And when the subject moved the hand, moved the finger, we observed a very clear increase in the oxygen and hemoglobin. However, when the subject moved the left finger, we cannot any change in the left motor region. So finally, we concluded this system can measure brain hemodynamic change induced by the brain functions. And so as you know, the functional MRI is very famous neuroimaging system. And the spatial resolution is very high at 53 centimeters, but the temporal resolution is about 2 or 3 seconds. And we have also the functional MRI, but the problem is the subject should be restrained, and also the system is huge, very huge. The weight is about 100 tons, and the experimental type was very limited. While the opticography has the advantage of low restriction and the small and light, so we can measure the human brain function under daily conditions. So that is a very good advantage rather than functional MRI, I think. And this is the inside of the optical cap, and this is the irradiation light, and the black one is just the detection light. And we compare the result using the opticography and functional MRI for the language test. And finally, we get a very similar image between the opticography and functional MRI. So maybe this result has an impact, because functional MRI is one of finger of the neural image, but the opticography has a little bit similar. You can get a similar image like functional MRI. And so actually, I want to discuss about the source of the functional signal. Actually, this is a microscopic image of the brain, and the brain is consists of the three types of the cell. First one is a neuron, and the second one is glia, and the third one is the capillary to supply blood. And we are measuring the blood volume change. However, it's not a neural activity. Neural activity was measured by electric device. And anybody doesn't know why the neuron was activated, why the blood volume increased when the neuron was activated. And now there are some hypotheses. For example, there is something mediator, NO or choline, CO2, or direct control from the neuron to the blood vessel. And finally, the diameter of the capillary increase, and oxygen and glucose supply to the neuron. However, anybody doesn't know the function of the glia cell. And so we have also tried to measure the source of the signal, hemodynamic signal, using the lab. And we can measure the neuronal activity using these instruments. And we are using the voltage sensitive dye into the rat brain. And also this system can measure hemodynamic change. So we can observe neuronal activity and hemodynamic change, activity, and when the rat was stimulated by sound. And this is the image. So this area shows the neuronal activity, and this area shows the oxygenate hemoglobin and deoxygenate, so hemodynamic change. Now let's have the sound. So measurement area was auditory cortex, and when the rat heard the sound, auditory neuron was activated. It's like a spike. It's because this is electric signal. And then